Welcome to the wonderful world of wastewater. Ever wonder what happens after you hear the swish of water magically taking away all that stuff that makes you go, yuck? The fact of the matter is, it isn't magic. Pee, poo, and toilet paper don't just disappear. Your waste makes its way through a complex network of pipes and pumping stations to a wastewater treatment facility where it is treated by Hamilton's wastewater professionals. Abiding by strict regulations set in place by both the federal and provincial governments, staff at the City of Hamilton take great pride in making sure wastewater is treated with the greatest of care and when released into the natural environment after treatment. Let's take a look what goes into cleaning that stuff that makes you go, yuck. The City of Hamilton collects and treats both sanitary waste and combined sewage through the over 1,740 kilometers of pipes that make up the underground wastewater collection system. These pipes travel from your home, business, and school to one of the two wastewater treatment plants. One servicing the needs of the Dundas and Waterdown communities, the other is located on Woodward Avenue and services the majority of Hamilton's residents and businesses. Let's take a tour of Hamilton's Woodward Wastewater Treatment Plant. The main pump station is where all of the city's wastewater flows to and begins the wastewater treatment process. Wastewater enters what is known as a wet well, an extremely large holding tank. 8 pumps are used to lift the liquid waste out of the wet well. Once the wastewater is pumped out, gravity moves the wastewater through the entire treatment process. The main pumping station has been in operation since 1964. The city is currently undergoing a major upgrade as part of the Clean Harbor program and building a new pumping station that will increase its pumping capacity to 1,700 million liters of wastewater a day. This substantial project will help protect homeowners and the environment from flooding and allow for increased storage during major wet weather events. This new pumping station is anticipated to be up and running by the end of 2021. In the channel between the pumping station and the headworks, ferric sulfate is added to assist in phosphorus removal. This step is extremely important due to the impact phosphorus has on the environment. Excess phosphorus in water bodies like Hamilton Harbor can result in the growth of algae blooms. When algae decomposes, larger amounts of oxygen is used and in turn has negative impacts on oxygen-dependent aquatic life. Phosphorus removal is critical. At the headworks, a mechanical filter known as a bar screen is used to remove large objects such as rags, wipes, and plastics from wastewater. 4 sets of bar screens with 9mm spacings are used to separate large debris. The screens are cleaned with a rake-type mechanism, scraping away the garbage that will ultimately go to the landfill. Essentially, anything that is flushed down the toilet ends up here. To keep our infrastructure strong and working for years to come, it is important that we treat the pipes, pumps, and equipment with respect by only flushing the 3 P's: pee, poo, and toilet paper. Everything else belongs in the trash. After the bar screens, 6 vortex separators are used to remove the smaller sand and gravel-sized particulate called grit that is not captured at the bar screens. The grit is also garbage and sent to landfill. In the primary clarifiers, wastewater moves slowly across long basins, allowing fine solids to settle out. Most of this material is organic waste that will sink to the bottom and is referred to as sludge. Other solid materials such as fats, oils, and grease will float and collect along the top. This is called scum. This process uses a chain and flight system in which bar flights skim across the surface to push scum to one end of the tank. Then, circles around to move across the bottom, pushing sludge to the front end of the tank where it will be pumped out to the solids treatment system. We'll see that process in a few minutes. As mentioned previously, algae blooms can appear in the environment as a response to increased levels of nutrients in a body of water. Aerobic breakdown is a natural process in the ecosystem by which microbes feed on the waste and recycle the nutrients back into the environment. If sewage was not properly treated prior to discharge, the natural system would become overloaded with nutrients. Bacteria would multiply to such large amounts that they would consume oxygen faster than it could be replaced in the water. This is why the aeration process is so important. These tanks are called aeration basins. This is a biological treatment process that utilizes aerobic or oxygen-consuming bacteria to break down organic material. Atmospheric air is compressed and then pumped through diffusers at the bottom of the tanks to provide an oxygen-enriched environment for the bacteria to thrive. This simple process helps to ensure aquatic life thrives after the treated wastewater is discharged back into the environment. Secondary clarifiers allow solids to settle out much like the primary clarifiers. There are two styles of secondary clarifiers at the Woodward plant. The south plant utilizes a chain-and-flight system similar to the one used in the primaries, while in the north plant secondaries, water wells up in the center of the tank and radiates outward in all directions. Two arms protrude from the central structure under the water. The arms spin around to collect the sludge that settles on the bottom. Archimedes screw pumps are used to carry a portion of the activated sludge to the solids process. This is referred to as waste-activated sludge. The other portion of the activated sludge is returned to the aeration tanks as a source of food and bacteria. This is referred to as return-activated sludge. In 2019, the city began a milestone project at the Woodward Wastewater Treatment Plant. A tertiary treatment process is being added, which will improve wastewater quality before it is discharged into the environment. The treatment process is intended to remove inorganic compounds and substances, such as the total suspended solids and total phosphorus. The addition of this process, which is planned to be operational in 2021, allows the treatment plant to meet the target set by the Hamilton Harbor Remedial Action Plan. During the summer months, water leaving the secondary clarifiers is chlorinated to remove potentially harmful bacteria, particularly E. coli. The use of a chlorine contact chamber increases contact time to ensure proper disinfection prior to discharge into the environment. Disinfection is only carried out during summer months as winter temperatures are too cold to allow these harmful bacteria to thrive. Although beneficial in the fight against harmful bacteria, active chlorine can be toxic to aquatic life. Therefore, sodium bisulfite is added to the water as a final step before entering into the environment to break apart the compounds containing chlorine. This is called dechlorination. The final clean water, or effluent, is then released into the environment from the treatment plant's main outfall and enters Hamilton Harbor. Although the effluent has now been discharged, there is still work to be done with the solid waste. Let's circle back. The first step of the solids treatment process is referred to as thickening. Using the sludge from both the primary and secondary processes, a polymer is added to the sludge to coagulate the solids. The thickened sludge is then carried over a belt with pores, allowing liquid to pass through while the solids are separated and remain on top. The separated water is returned to the pumping station to be cleaned again while the thickened sludge continues on for treatment. These machines are called gravity belt thickeners. These are the anaerobic digestors. This is another biological treatment process, this time utilizing anaerobic bacteria, meaning that they operate in the absence of oxygen. Anaerobic conditions are maintained by isolating the chambers from the atmosphere. Internal temperatures are maintained at around 37 degrees Celsius. At this temperature, the bacteria thrives, breaking down the biodegradable material and destroying pathogens. The digested solids, now considered biosolids, are rich in nutrients and can now be used as a fertilizer. Wherever organic matter is degraded without oxygen, methane gas is produced, and we produce a lot. The large globe you see from the highway is our methane storage tank. This gas is purified to produce renewable natural gas and analyzed to ensure its quality meets union gas specifications. It is then injected into the utility gas grid. We also utilize this gas to produce electricity. Hamilton is the first municipality in Ontario to be approved to build a generator for sustainable green energy by the Ontario Electricity Financial Corporation. This project is one of the most innovative, large-scale examples of biogas cogeneration in Canada. Our cogeneration plant produces enough electricity to power approximately 1,600 homes annually from the methane gas of our wastewater treatment process. Following digestion, the biosolids are further treated in a stage called dewatering. This process utilizes 4 large centrifuges to remove excess water. A centrifuge is a rapidly rotating machine that applies centrifugal force to separate any remaining liquid from the biosolid material. The biosolids are now referred to as cake. From the over 500,000 residents the treatment plant services, the Woodward plant produces an average of 100 tons of cake every day. That's approximately 37,000 tons per year. To put that into context, a male African bush elephant can weigh up to 7 tons, meaning we produce around 14 elephants worth of cake every day. In the end, biosolids cake can be spread on agricultural fields as a fertilizer, or on mineland where the cake helps to return nutrients to the earth and stimulate plant growth. In 2019, the city began the process of building a new facility changing the way in which biosolids are treated in Hamilton. We will be moving to a high-heat drum dryer technology. This will remove almost all the water from the cake, forming pellets that can be sold as a pathogen-free fertilizer and can be used on crops produced for human consumption. Added benefits of this change include a more marketable material, less odor and dust, fewer trucks required for transport, and less waste to landfills. The wastewater treatment process is closely monitored through a combination of laboratory analysis and analytical device readings. Hamilton Water staff regularly collect samples from different stages throughout the treatment process, which are analyzed at the city's own nationally accredited environmental laboratory. Staff are also able to see real-time analysis from a variety of devices that are wired into the city's internal monitoring system called SCADA, which stands for Supervisory Control and Data Acquisition. It's an electronic system which allows plant staff to view process parameters, data trending, and the status of equipment such as pumps and valve positions from one central location. Much of the wastewater treatment process can be controlled remotely through this system. Because the treatment plant is the largest single source of processed water flowing into Hamilton Harbor, the quality of our plant's output has a direct and powerful impact on the harbor's water quality and environmental health. Creating a healthy and sustainable Hamilton Harbor is important to ensure we safeguard an irreplaceable resource that meets a variety of community needs. The harbor has become a central element of Hamilton's ecological, social, economic, and recreational communities, and with continued focus and improvements to wastewater treatment, the harbor will continue to meet these needs for future generations.